Hello dear space lovers, welcome to the Explorers. Today we're going to talk about the satellite NISAR. I hope you would like our content, so let's start the video. So first, let's get on to the introduction of NISAR. So what's NISAR is? How does it go term NISAR? Let's get answers now. NASA-ISRO SAR, NISAR. It's a low Earth orbit observatory being jointly developed by NASA and ISRO. NISAR will map entire globe in 12 days and provide spatially and temporally consistent data. So wait, what does spatial and temporal consistent data means? Spatial refers to space, temporal refers to time. Spatio-temporal or spatial-temporal is used in data analysis where data is collected across both space and time. It describes a phenomenon in certain location and time. For example, changes across a geographic area over time. NISAR's data is useful for understanding changes in Earth ecosystems, ice mass, vegetation biomass, sea level rise, groundwater and natural hazards including earthquakes, tsunamis, volcanoes and landslides. NISAR carries L and S dual band synthetic aperture radar SAR, which operates with sweep SAR technique to achieve large swathe with high resolution data. Here we go to new term SAR, which you might be unfamiliar of. So let's see what SAR means. So what is SAR and how does it work? Synthetic aperture radar SAR refers to a technique for producing fine resolution images from a resolution limited radar system. It requires that the radar be moving in a straight line, either on an airplane or in case of NISAR, it's in orbiting space. It seems very complicated, right? Okay, let's understand the principle behind it. We will get an idea what it is exactly. The basic principle of any imaging radar is to emit an electromagnetic signal which travels at speed of light towards a surface and record the amount of signal that bounces back or backscatters and its time delay. In this animation, you can see how the signals are transmitted and how the backscattered signals are received and analyzed. The resulting radar image is built up from the strength and time delay of the return signal, which depends primarily on the roughness and electrical conducting properties of the observed surface and its distance from the orbiting radar. The wavelengths that remote sensing radars use to observe the Earth's surface are microwaves, typically in the range of wavelength of few tens of centimeters. Because the radar signal loses energy as it travels, it is equivalent to the beam width, which is wavelength divided by antenna size. By the time it hits the surface, the beam has spread dramatically, producing an image resolution which is insufficient for most of applications. SAR is solution for this dilemma, as it can vastly improve the resolution of the image. So as I said, SAR improves the image resolution. Let's see how it's done. To improve the image resolution, we should decrease the spreading of signal, which can be done by increasing the size of antenna. NISAR carries a 10-meter antenna. It is impossible to increase the antenna size to kilometers physically. So here the SAR techniques take advantage of fact that radar is moving in orbit to synthesize a virtual 10-kilometer long antenna from the physical 10-meter antenna in the direction of light. As the radar moves along its path, it sweeps the antenna's footprints across the ground while continuously transmitting pulses, which are short signal bursts separated by time, and receiving the echoes of the return pulses. Now let's see how does synthetic aperture radar process the image. Synthetic aperture radar processing provides a complex image, a pixel with associated amplitude and phase. Once calibrated, the pixel's amplitude is proportional to the reflectance of the surface. Reflectance means how much light is reflected from the surface. The phase is proportional to the distance the wave travels between radar and ground, any delays due to traveling through the atmosphere, and any phase contribution imparted by the reflectance of the surface. The NISAR spacecraft will accommodate two fully capable synthetic aperture radar instruments, NASA's 24 cm wavelength LSAR and 10 cm wavelength SSAR provided by ISRO. NISAR has around 240 km swathe, 7-meter resolution along track and 2 to 8-meter resolution cross track, depending upon the mode. So this is how the SAR works and improves the resolution of the images. I hope you understood about what NISAR is and about SAR technologies. So it's the end of our first part of this topic. I will be back with part 2 soon. Thanks for watching.